Hello, hello, hello. Welcome to this very special episode of the Julia Dispatch podcast. I'm still Chris Rakakis, but around me, we have a lot more people than usual, and we are live and in person. This is so cool. I mean, we always feel more comfortable behind computers, at least who we are, but it is cool to be live sometimes too. So, we're going to have to do a lightning round here, everyone. So if we can do introductions, we can start on the end here, and we can go all the way down. Let's start with let's do name, affiliation, number of years using Julia, and which package you're associated with, right? Because that's more of who you are, right? So let's start with you on the end.
Yeah, hi everyone, I'm Milan Kluver. Affiliation is University of Oxford. Years of Julia is probably touching 9 now, 8 or 9. And I'm most known for SpeedyWeather, an atmospheric model.
Hi everyone, I'm Raf. I'm affiliated with Nina in Oslo these days. I'm most known for probably rasters, dimensional data, geointerface, a few others packages.
Hi everyone, I'm Nathaniel. My current affiliation is Harvard University. The packages that I'm most associated with are GeoRegions.jl and NASA Precipitation.jl, which downloads lots of stuff. Yes, okay.
Hi, I'm Felix Kremer. I'm affiliated with the Max Planck Institute of Biogeochemistry in Germany. I'm coding in Julia now for 7 years. I'm mostly associated with Yax arrays and also partially with dimensional data, and currently working a lot on permit schemes.
And we'll pass it down to here.
Hello, I'm Simone. I'm affiliated with MIT. I've been coding in Julia only for 3 years and a half now. I'm mostly known for Oceananigans, Klima Ocean, and Klima CIs. So everything related ocean and CIs.
Hey there, I'm Gaël Forget. I'm at MIT as well. I guess I'm at MIT. I've been using Julia probably for 8 years at this point, and I developed a collection of packages within the Julia Ocean and Julia Climate organizations, such as mesh arrays, climate models, drifters.jl, climatology.jl, and a few more.
Hey, I'm Anshul. I am now with Julia Hub, but been using Julia for about 6 years, I guess, since 2018. Packages I'm most affiliated with are Makie, GeoMakie, and a bunch of random geospatial packages. I guess Geometry Ops is a big one.
Hello, I'm Alexander Bart. I'm from the University of Liège, and I work with Julia since Julia 0.5. I don't know if it's maybe 8 or 9 years. And so I'm mostly working on packages like DivineD, Dinkai, and NC datasets in the Julia community.
Hello, I'm Maarten Pronk. I'm at Deltaris and Delft University of Technology. I think I've been coding in Julia for 8 years now, and packages are geodata frames, geointerface, and really a lot of file packages, file drivers. Back to you, Chris.
Yeah, so if you couldn't tell from the audience that we have here or the panelists that we have here, there's a lot of folks here that are, geosciences and earth sciences. This is because we're at the Julia EO community event. So this is Julia EO 2025. There's actually a bit of a picture back there on it. So we're here in the middle of the Atlantic Ocean in the Azores on Terceira Island, talking about earth sciences and how that's progressing with Julia. So as a quick fire round to kind of go through all the different panelists here, something that everyone can make a response on. I want you to go, what is your current favorite thing about Julia, and what is your current biggest issue? Just a quick fire, one after the other. Let's start with Milan.
Performance is always my main first thing, but what I'm mostly annoyed about currently is pre-compilation time, and I would love that to be just much faster.
Yeah, mine's also performance, probably a common response. My biggest problem is probably compiling to binaries is still really difficult.
I would say that my favorite thing about Julia is one-based indexing and the fact that it's open source. And the thing that I don't really like that much about Julia right now is the plotting ecosystem, unfortunately.
Ooh, and we'll have some questions about that one in a little bit.
My favorite thing is multiple dispatch, and I think most annoyed at the moment is some strange allocation issues that I have with Julia 1.11.
Alrighty, specific.
For me, my favorite thing is definitely extensibility and multiple dispatch. Also for me, probably the worst thing is pre-compilation, since our package take a lot of time to pre-compile.
Right. So maybe my favorite things, because nobody has pointed to that, is things like Pluto notebooks and Makie, that I think are some tools. The package managers as well are like one of my favorite things to advocate.
Oh yeah.
The biggest issue that I have, I'm not totally sure, but I would say adoption could be larger. Well,
Yeah, so I think obviously performance is a big one, but my main thing that I appreciate about Julia is probably just composability and the way that the ecosystems have developed, so that I can pass in a geospatial point into a differential equation solver and plot that. And the amount of glue code that you need to do that is either non-existent or very, very small. The one thing, my one biggest gripe is probably pre-compilation and the lack of binaries. So I guess that's two.
Yeah, so speed is definitely a great feature in Julia, and also code specialization. So you can write really nice generic code, and it will be still very fast. And yeah, one of the problems is maybe the package installation, but that's also due to the generality of Julia. So it's difficult to have all of it.
So there are many things to like, but I think like Anshu, I have to go for composability. And the thing I hate is also composability, because it gives me so much integration bugs, and I find it quite hard to test on a larger ecosystem scale for that.
Alrighty, so now you got a quick introduction to each individual here, right? So we got people who are working on a lot of large data tooling. We have a lot of people who are working on building climate models, right? But there's a whole area that we call, Earth sciences that includes it all. Now let's get to some of these like spicier questions, right? So the first thing I want to kind of talk about is, throughout the different areas of the earth science community, I know that there's not one specific earth science community. There's many, right? But, where is Julia as a player within this space, right? How big is Julia? What is its adoption like? What is its adoption within different agencies? And where are you seeing growth, and where are you seeing not as much growth, right? Does anyone want to kind of take this question?
I can start.
Yeah, go for it.
So I see some adoption. So we see, I think 2 years ago, we did a smaller community event at the EGU with 30, 35 people, and also some modeling. So there's a modeling community in different parts that use ODEs and that. There's nowadays also the European Space Agency takes up some interest in Julia. At least they have it on their radar. It's not like they push for it, but at least there's some people using it. There's also some calls where it's especially asked for that you also develop stuff for Julia. But yeah, I think for the other agencies, I can't answer.
Yeah. So talking specifically about the climate modeling community and CFD, I think Julia really fills a niche because there is a lot of demand for a language that is performant but is very easy to use. So by using Julia, you can really build these type of softwares that get adopted very quickly by users. So in our case, and I think also Milan can confirm, when you give to the public CFD software that is easy to use and fast, people adopt it very quickly, and you rack up users very fast.
Yeah, maybe just to pick up on that, especially the climate modeling community is so much built around a lot of legacy Fortran code that no one really just wants to give up. And so even with the emergence of Python, people were really hesitant to start something from scratch. But once Julia came on stage, there are now several initiatives where people have said, like, this is a great language. We want to make that possible. Kind of replace Fortran with Julia. And therefore, really, the two-language problem that we currently have, using dusty old Fortran models for performance and for all the legacy code, and then doing the data analysis in Python, Julia can definitely tackle that by covering the entire spectrum from performance to visualization.
All right, I'll say a couple of things. One is, first off, a shout out to this event and the team that's organized it, the Air Center and João Pinello especially. I think this event in itself has done a lot in getting us together. Some of it had never met before, and we are going to continue this, and so shout out to Julia.io, first off. Secondly, maybe I have a slightly different view on the sort of the competing language aspect. In my mind, one of the real strengths of Julia in terms of what it is today and what it can become is that it interoperates with everything, and generally the community is very inclusive. And so I think we are gradually, percolating in many ways through the community and getting more and more people convinced as we demonstrate its skills. I'll say one thing about, agencies. I guess in the US, often what I found is that, the infrastructure work is sort of not really favored by, most of them, NSF being one specific one. But I'd highlight NASA for being really a promoter of open science and recognizing the value of a language like Julia that can handle very large data sets, very efficient programming. And I think there is, with my colleagues at JPL and within NASA programs, I think there is room for a lot of growth there. I'm hoping that the universities also see their interest in getting their students on Julia as opposed to just necessarily Python. I think that's one thing that we are maybe struggling with, in a sense, is getting more young people on board faster.
Something reacting to Milan about the Fortran code and the C code, which powers a lot of the Python ecosystem. I think once we are able to in Julia to compile down Julia code into libraries which are easy to use also for other ecosystem, I think it will help a lot also to drive the adoption that's not every user who uses Julia codes does not necessarily interact to the Julia. You can keep this workflow, but indirectly using Julia as a kind of replacement of Fortran, which is then wrapped with another language like Python or R.
Yeah, just I just wanted to give a different perspective. There's a lot of like oceanography and bigger scale perspectives in a field like ecology and biogeography. Like people are using R, and most people don't really have a large need for performance. So you see adoption of Julia in like extreme cases, basically when R breaks or Python breaks, or when there's some project that has really performance needs. So it's very skewed to a very specific set of problems rather than being something the field really uses. And that's slowly changing, but it's very niche. Yeah.
So I'd just like to chime in that a lot of the things that we've been talking about has been from the modeling side. When it comes to data retrieval, downloading, and analysis, I believe that Julia packages for those things are still lacking, especially for the high-end front user. We do have packages like rasters and other packages that do like subsetting of data, but the application towards data sets, specific data sets like NASA data sets or ECMW data sets, like big data sets that a lot of centers have that climate scientists generally use. These things are available in Python with Xarray, but they're not available yet with Julia, which is why sometimes we're seeing a lot of the pickup in the development of a lot of pickup in Julia is not quite there yet because it's just not easy for people to transition from Python to Julia for these higher level cases, I would say.
So yeah, I think that this really kind of highlights, and I think it's something that is a smaller episode with fewer people. I think it's harder to kind of highlight this effect, but I think that one of the things that we kind of see is that saying like, oh, Julia has X percentage of 52% of adoption in this community is very hard to come up with because there's a wide range of what we call the community. Even with earth sciences, it sounds like there's a lot more inroads that are being made within the climate modeling sphere than it is within like the data science sphere, and so there could be a lot of different pros and cons throughout the different areas. So I think this really highlighted that very nicely. Now, speaking a bit of the climate modeling aspect, there's a few different folks here who develop different aspects of what we call like portions of climate models and parts of climate models. I think there's SpeedyWeather, Oceananigans, there is ClimaOcean, there is MIT-GCM, right, which is wrapping some other pieces as well. So there's all these different climate models. What makes why should someone be using, why would you recommend that someone uses Oceananigans over another software? And what specifically has Julia allowed that makes some of these newer ocean tools competitive in this space of climate modeling, right? Because there's got to be hundreds of maybe at least tens of ocean models created before. Why are these new tools in the ecosystem, and why are there so many, and what are they really kind of capable of? Where are they getting adoption? You want to pass it over here?
Yeah, sure. So I think it depends on who you're looking to. So definitely for climate modelers that have experience with other models that do not really need to have a Julia language, the advantage of building these tools is for speed, because Julia allows performance, allows targeting GPUs, and that's the advantage for these type of people. For the young people that are starting to interact with climate models, it is for sure the ease of use, because Julia allows you to have a model that is very easy to interact with, very easy to use, and very understandable. So I would say that depends on the target.
So I'll chime in two things. One is, my department having produced both the MIT-GCM in the first place and Oceananigans through, you guys, I think there's a real coherence between the two, which I think is a strength. That at this point there are applications where MIT-GCM, which you can now use through Julia with Julia by using MIT-GCM.jl. You have things that are like in production mode, kind of state of the art in terms of the user cases and stuff like that today, that are limited, however, in terms of scaling, right? So as something like ClimaOcean becomes more and more ready and tested against observations and so on, we will be able to collectively, transition from one to another for whatever is needed, and ultimately, I think, leverage the strength of one another. Another comment that I'm going to make is about my Drifters.jl package, which is relying on the beautiful ODE environment that we have in Julia. And the most direct comparison I can make, in a way, is another software that is essentially a Python interface that generates C code underneath. And so you have this sort of situation where, the development cycle of all of this is cumbersome. It's a bit of a, it's a very powerful tool, but I think it also has very clear limitations. And so that's why I decided that was one of the things I was going to do first with Julia, is to sort of build an alternative to this. And I'm seeing, as I go through this, a lot of people being interested. So I think there is tooling for numerical calculation in Julia that is really, really powerful and helping the community.
Yeah. So I just want to throw a clarification out there to some of our viewers that are not as into this community. MIT-GCM, right, is a more, it's a MIT built climate model that was written in Fortran that now has Julia level interfaces, while Oceananigans is a Julia first kind of a portion, and a lot of the Julia first portion for the scaling, as we kind of learned through this conference, has been due to the ability to be able to use these multi GPUs and kernel abstractions, and so that seems to be actually one of the things that's really leading to this adoption. And but without having to throw away the old tools, I mean, there's a lot of tooling now that's being able to be used, so that way the older Fortran models are able to be used nicely through Julia to be able to help us through this gap while the the newer tools are being fleshed out, right? So I think that I just wanted to kind of give a bit of that background there, and then I think that we still got some more modelers over here who have some comments.
I really want to highlight this aspect that Gael mentioned about the development cycle. So really this usability and the interactivity that you have with these models. To give an example, I believe probably still nowadays, but definitely back in the days, a lot of PhD projects were built around this idea of like, okay, you somehow have to get that model, you have to compile it, it probably takes you a couple of weeks to figure out how to do all these things, and then at some point maybe you're able to run a simulation, and by the end of a PhD you kind of analyze the data, and then you're 3 or 4 years in. I believe with these interactive new Julia models, what we really can do is absolutely shorten this time. So this is one of these killer aspects that I find, where one of my master students basically managed to run Speedy Weather within like 2 minutes. And this is exactly where suddenly you can, it's way more intuitive to use. You can interactively play with it. You understand what certain things are working, where are you facing errors, what works, what doesn't. And so within a week, you can probably do the research that otherwise would take you months. And I think this can be absolutely a killer aspect going forward.
I just like to speak from someone who is not a climate modeler developer, but someone who uses the climate models. So basically, what Julia does is that it kind of replicates it kind of replaces the need to create your own modules in Fortran, or it makes it easier to. It also makes it easier to simply just take out, replace the default modules with something new, like with the multiple dispatch options. You can, like, for example, replace the land sea topography with something completely different, or you can create an entirely new convection scheme and just put it into the model. It's very easy to do that in Julia, and compared to, I would say, Fortran, because Julia itself is a high-level language. High-level language is easier to write compared to Fortran. Yeah, that's one of the values as well.
Yeah, so that I really love this discussion, because it really is highlighting a lot of very specific aspects that you can point to of why Julia is making inroads into the climate modeling community, and seems to be a lot because if I give a summary, the ease of the GPU usage, but not just that, but also you're using the same high-level interface that is actually the code that is used for the model, which means that if you need to make small modifications of the model, like add your own convection code or something, suddenly it's so much easier as a user to modify it towards your needs. So it sounds like there's some really strong use cases, at least in the climate modeling field. Transitioning over to the other topic, though, right? Because there's also, you gotta.
And just as an add-on to this, it's not only about modification. It's also from a science perspective, especially important that we can dig very deep into the core, because I also try to not on a modeling perspective, but I try to understand what certain code in Java was doing, and then I went down some rabbit hole, and then it was pointing to some other folders, and then at some point I just gave up. In Julia, it's just an edit away. So you can especially understand what the tools you're using are actually doing. And I think that's very important from a science perspective.
Mm-hmm. Mm-hmm. Yeah, so that's a lot of really nice points for the climate modeling. I want to shift the topic over to the data, because there's also, as part of the earth sciences community, there's a lot of questions about, there's a whole lot of questions about, the usage of big data. And that's another big field where people are saying, big data, you need a lot of compute, you need to use your compute resources effectively. Now, for the folks here that do use big data, lots of data, what are your favorite big data formats? Which are the formats that are, the best developed and the best supported in Julia, or which are the ones that you're kind of seeing are the future that you'd start recommending people to use?
As someone who uses the data very often, NC dataset, so NetCDF is the one that's most commonly used, at least in the climate sphere. We're very lucky to have Alexander, who does development on NC datasets, and he's kind of been a lifesaver for most of us who use NetCDF in Julia. Yeah, so that's so NetCDF, HDFI, which is also NetCDF, can also be read using NetCDF. Those are mostly the file formats that I usually use in my work as a climate scientist. Yeah. Anyone else?
Yeah, thanks for these nice words. And yeah, indeed, I also use NetCDF most of the time, and I think it's a very nice format. It has stood the test of the time, so it's around since a long time, and you expect it to work also in the future. And there are other formats which are really gaining a lot of attraction, like ZAR. But there are a lot of things in ZAR you see that has been really developed for Python. So in meaning that all the metadata numbers are untyped. Metadata only has numbers, strings, and yeah, that's essentially just all of the primitive types. So Julia has a much richer type system, and it's much goes better to the with NetCDF where you have the equivalent types as well. So.
Well, I just wanted to. Yeah, so I just want to throw something that comes to my mind here. I don't know if other viewers would have this. Normally we were talking about big data. A lot of people these days in other communities are, not specifically the earth sciences community, but a lot of just like data communities are usually talking like Arrow and Parquet. And so I think it's a very interesting thing to just point out that it seems like this community has has different data formats and such that have really they've really clung on to for reasons. And I'm sure that you'll want to address some of those pieces there.
So just to give some context, right, an Earth observation, a lot of your data is images from satellites. And that's basically very large n-dimensional arrays, 2-dimensional, 3-dimensional, maybe you have a time dimension, maybe you have some other dimensions as well. And so in that, I'm very happy with the idea of ZAR. Some of the implementation aspects definitely could be a lot better. But I think that there's a lot of effort in now converging, especially for these gigantic data sets that are put out by agencies, which are sometimes millions of files, and where earlier you as a user had to put your head into it and say, okay, I want this particular file for my one thing that I want to do. Now with emerging technologies like ZAR, Kerchunk, IceChunk, which is a new thing, the user doesn't have to think about that. And we have access to a lot of these in Julia now. So I would say that probably ZAR is one of my favorites. Touching on what you said about Parquet and Arrow. So we do use Parquet and Arrow in the geospatial community mainly for vector type geometry. So, polygons, or maybe it's the outline of your house, maybe it's a country. But those generally tend to be manageable. And things that you use ZAR or HDF or NetCDF sometimes for will be gigabytes, terabytes, petabytes, right? So this is the scale we're talking about.
I had one little more thing, which is not everything is big data, but sometimes it's about, we have say 100 gigs of data and we want to subset it though. And so Parquet is something I was not very familiar with, but it's come in my realm in the case of we have a lot of data that are point-wise collected in the ocean, and a way to make them available and in this kind of cloud integrated way that was subsetting is Parquet, and I think it's one of the things we'll see more of. Even if it's not for huge data sets, most of what I do, in fact, doesn't really qualify as huge data sets. But things like, Chunk, NetCDF, ZAR, Parquet are becoming really, really useful, important. And ultimately, we are starting to really hit the limitation when we distribute our climate model output, which are becoming at very high resolution. Some of my colleagues at JPL, for example, have generated simulations where we have 10 petabytes of data. The issue on some level is not as much what is the format or how do we, but like the price point of putting it out there and what sort of services do we have. So I just wanted to sort of highlight that aspect of things. I'm hoping, that agencies might subsidize sort of big data lakes. I think the EU does some of that, maybe more than the US at this point. we have a real limitation there in terms of making our data available.
I just wanted to maybe add some perspective on the idea, the file types idea. Like a lot of like data loading packages in Julia, and we have a lot of abstractions for data loading that are actually generalized across lots of different backends. So we're not really tied to anything. We have like disk arrays. We'll do chunking patterns across any kind of backends, TIFF, ZAR, NetCDF. Common data model will do CF standards across lots of 4 different backends. And geo interface we have, it can use Arrow or Parquet or old formats like shapefiles. So we've tried to set everything up in a way that changes in data sources don't affect us very much. All the tooling at the mid and higher levels are kind of agnostic to what's coming in. Yeah.
So I think in summary, I think that there's two main pieces I kind of would pull out here. One is that just kind of a funny point here that depends on who you're talking to what big data is. Sounds like 100 gigabytes is not a lot of this tiny data for this crew, right? It's got to be 50 terabytes or petabytes or more to be big. And so the idea of big data and all that, I guess, is a very context dependent and culture dependent type of question. And now I like what you brought up here, which is like you started getting into one of these next topics, which is what are the aspects of Julia that particularly make it good for data science aspects, right? It seems like one of the things you brought up here is that a lot of the analysis packages are not particularly written for one data type. They're generic to a lot of data types by using tooling like multiple dispatch and like table interfaces and things like that. Are there any other like major pieces that you'd point to in the Julia ecosystem that make Julia especially good for these really large petabyte type of data?
Disk arrays.
Yeah, I'm going to say Makie, and especially like GL Makie, that allows you to interactively visualize large data sets and create animations that are sort of the only way to really rapidly sort of get a sense of what's going on in these massive sets of files. So I think the visualization ecosystem in Julia is really strong in that way.
I would say also the Earth science data is pretty heterogeneous. So having something really flexible language, that helps a lot. So one particular case in oceanography, for example, you can have a large collection of profiles with all of different lengths. So you essentially have a vector of vector, and that you cannot represent as a matrix. And in Julia it's really great because it can handle this kind of data structure really, really fine and efficient.
Yeah, so I think that one of these comments here started sliding into the next question that I wanted to get to, which is that one of the things I saw from the earth sciences community here was that there's a lot of use of Makie in particular, right? There's a lot of these, super cool, here's a picture of the Earth. Wow, that's a super cool Earth, and it's spinning around, and there's a bunch of ocean currents going along it, and everyone's using Makie around here.
No.
Okay, not everyone. All right. But I think that one of the big things is that Makie hasn't gotten as wide adoption throughout a lot of the Julia community, right? I'm wondering, so this seems to be the early adopter community, and it seems like there's a lot of good reasons, like Makie is so good for the GPU accelerated super large scale data sets. What do you think in terms of like the greater adoption though? Like is Makie ready for is this the first thing that you teach to your undergrad now, or what are the remaining pieces that you kind of think are required for Makie to start to become more of a Julia standard for visualization? And I'll throw it right over to Anshul here.
So I think one of the big things in any package is how easy it is for someone who has no clue about any of this to use it, right? And so that's somewhere where I think plots did it really well. In Makie, we're not quite there yet. So I'll give you an example. When you plot a heat map, you don't get a color bar with it. Most other plotting packages you do. In Makie, we didn't have that capability until very recently. And so now, earlier it was a technical question. Now it's a question of what's the best interface for this? What does the user see when it gets returned? So it's these sort of user interface level questions that we have to answer. But I think that in terms of flexibility, there's nothing that matches it. And in terms of, as Gael said, rendering speed, the flexibility of transformations. I wrote GeoMakie, the initial implementation, in 400 lines of code. 300 of that was figuring out how to plot latitude, longitude lines most efficiently, right? So it's the beauty of Makie is just how flexible it's been made. And of course, there's a lot of stuff that underpins that. But yeah, I think, would it be the first thing I teach my undergrad? No. Would it be the second thing? Yes. Because I show you what to do, I show you how to do it, then I say, okay, you know what? You've understood this now, you've understood perception in data visualization, right? The art of telling your story, but also of visualizing your data so that if there's something you don't expect, it's obvious, which is not that easy sometimes. So
Okay, this is coming from someone who has tried using Makie several times and has generally switched back to Python backends to plot. I use ProPlot for reference for those who are for reference, which is a Python package that was built on PyPlot. The reason why I keep switching back from Makie to Python is because there are a lot of small details that have not yet been fixed. So for example, across different functions, keyword arguments that are meant to reference the keyword arguments for one thing are not standardized across functions. There are also some other things, like for example, Ctrl F, you can discretize your colors very easily. You can't do that on heat map. And as someone who deals with data that is quite big, I prefer to use heat map over Ctrl F. There are like very specific reasons why I prefer to use ProPlot over Makie, and it's just that, at least for me, the things that I need, just where the cards fall, it's just Makie is not quite there yet for me. I'm also a bit of a perfectionist when it comes to graphics. When it comes to, I want to be able to copy something and paste something, like copy from an old code and paste into a new code, and like things like that should be easy to do, or at least it should be easy to modify once you copy from an old place to a new place. And Makie's just not quite there yet. Yeah.
I'm just going to throw in a couple more things. One is, it's related to this in many ways. Julia has a very good sort of interfaces to all sorts of other graphics package, and a lot of people I think will be doing that first, right? They come to Julia, they already know how to plot with PyPlot or whatnot, so they're going to use that backend. So maybe in a way that's an obstacle to making it as the sort of the one solution. A sort of idea that throughout there is it'd be nice, for example, if somebody is used to doing their plotting in a certain way in Python, that we'd offer some kind of interface where you just copy and paste your Python code to a Makie interface that then parses that and puts it into Makie. That would be sort of maybe a bridge that could be useful. Just a thought.
So I love all the spicy takes here. Felix, go.
So I'm using Makie mostly for interactive visualization. So I think that therefore it's really, really nice that you can plot GL Makie. You can quite easily set up a dashboard. I tried it sometimes with Pluto. I tried it with other tools. I didn't get there. I think Makie is much more flexible in that. And the other thing I think that could drive, or is certainly also currently pushing Makie a bit more, is before 1.9, being dependent on Makie is a huge step. Now we have extensions. Now we can just have a Makie extension on a package and then have some plotting code there so that plot of your type just works.
Yeah, let's keep passing it around. More spicy takes.
I think, like Nathaniel, I have a sort of love-hate relationship with Makie, and I tried to postpone it for a long time, and maybe for publication plots, I would go back to something else. But I think for Julia EO climate models, like Gail said, we have huge outputs. And like Alex earlier said this week, you really need to plot the answer of your algorithm to see whether it's actually working or not. And if I have 1 billion points that I need to visualize and explore, only Makie will do that. So I'd say it's absolutely essential for my research.
Yeah, so I mean, just to round it out, I think definitely there's a lot of rough edges, right? But and please raise an issue about that contour F thing, by the way. But yeah, I mean, in general, I think the more people we get using it and sort of understanding, in a lot of package development workflows, what happens is that the developers are too far in to really see what the new user experience is like. And so when you sit with someone who's never used this thing before and they say, oh yeah, I don't understand this, you say, oh, I can write documentation about this. And that's a hard thing to do, right? Funding-wise, time-wise, it's not particularly easy. But I think there's a lot of stuff in Makie that we just have to document a lot better, right? Like I could tell you how to discretize your color map right now, but I don't know if you'd find it anywhere in the docs.
Yeah, so I think in general here, it sounds like there's a strong emphasis that Makie is the only tool that can do a lot of things, right? It's the only tool that can do a certain level of interactivity with these huge data sets, and so you have to adopt Makie because it's just like the best thing out there for this. But it really hasn't really hit the full user experience to be simple enough so that way even for the small data sets, you would still make use of it, right? So, but it sounds like it's really starting to make it progressing. We have some of the Makie developers here talking with the users and finding out like what they don't like about it. I mean, this is why we pull the community together, right? It seems like it's improving. Could you give a time estimate of exactly how many days you think it'll be before his issues are solved? How many days? That's all you get to say is a number, one number.
All right. I'd give it about 400.
All right. So 400 days and that issue will be solved. Don't worry.
I don't know about that issue.
All right. So I think that one of the other things I wanted to talk about here is scale, right? Because for Julia, we talk a lot about how fast the computation is, and we do GPUs, and we're talking about big data and such. But I think a lot of people here within the climate community, you're also known for running things really at scale, right? You don't say like, my big computation is me using all 32 cores of my MacBook laptop, right? And there's a lot of people here that are really running some things at scale. I wondered if you could address that a little bit, right? How well has Julia done for running on HPC clusters and large scale compute? What have you been doing in terms of scale? Like where have you been able to push Julia? Is it at I've been able to use one giant A100 GPU, or are you using thousands of GPUs, or where have you been seeing Julia? How scaled has it been, and what are the current next goals in terms of the scaling? Who wants to take that first?
So with our Ocean model, we have tried to run on 4096 GPUs in the Perlmutter cluster. So these types of computations are required when you do like very high resolution Ocean models. And I think that Julia is actually very, very good for these types of computations, but there's still something to improve. Especially because what we use now is a wrapper over MPI, which is well made, but there's always a little bit of problems in configuring MPI correctly on the cluster. So all the well-known problems of configuring MPI are not really solved by using Julia in the same way as Julia solves usability or running on a GPU, for example. So you go back to all the problems, let's say, of classical C code or Fortran code or something like that. Let's say, so it's not necessarily worse than running on C code, but it's not necessarily so much better, let's say, like all the rest of the Julia ecosystem, I would say.
Oh, sorry. Thank you. So I think the issue is that a lot of HPC code assumes that you're compiling your code for the HPC cluster with the MPI library for the cluster and things like this. So it's rather the kind of old way where you are specializing your binary to the cluster, and that's quite difficult indeed to get for a generic package like Julia to help with this specific use case. Yeah.
However, I also have a couple of counter examples where over the last years we've been trying to use Julia on a couple of like a little bit more exotic chips, for example. So we use these like Fujitsu A64FX chip, which had like float 16 support, for example. And I remember a hackathon where a lot of people using C and Fortran, where basically like somehow trying to figure out how to make their compilers work, how to get the most of the performance out. But actually, for us as a Julia, we just relied on LLVM, and it just worked. And so some of these situations just really, got me very positive about this like flexibility that you can just like as a Julia user, you can basically just rely on LLVM. It's often, I'm not a compiler person, but even for me, it's relatively easy to check whether it's actually using some of these specific functions that like certain CPUs allow you to use these instruction sets, and that is just amazing. And I think having a Fortran compiler at hand makes that much harder, and you need to know much more in order to actually get this done.
Alrighty. So I think that one of the things that we always like to, ask for all the people who come onto the Julia Dispatch podcast, even if it ends up being, 8 or 9 folks, is actually I forgot to do a count. Yeah, it is 9. Yeah. So is call to action, right? Because one of the big things about the Julia community is that it's still growing, right? We're still making a lot of things. We're making a lot of tooling. So I'm kind of curious if we could go down the line and just kind of say, okay, I know that there are certain things that people have been asking for in terms of, I need to be able to build binaries, though it sounds like a lot of, the binary building has been, addressed in version 1.12 or, well, it's not out yet, but, it should be out soon. If you haven't seen the other episode with Jeff Besenson talking about, how to build binaries with the next version of Julia, go check out that episode. But so there's some things around binary building that's been addressed. There's some things around package precompilation. We're still getting better. I mean, there's a whole discussion by Tim Hooley about what's been done before and how it's still continuing to progress, right? So there's a lot of things that are still ongoing and a lot of things are being addressed. But what is the next thing that you want to see addressed in Julia? Like if you could like just ask for one thing, what would you ask for to just exist tomorrow? Let's go down the line and everyone's last. Or if you need to think about it, feel free to pass the microphone on for a bit.
Anyone wants to start?
I'll start. As someone who works more on the data side or the download and retrieval of the data side, I think what we need are more people who are willing to dive and experiment and create packages to download various data sets, because of course all different data sets have different usernames and retrievals and different ways to retrieve them. If you're using a data set that has not, especially an Earth observation data set, like say Aquaterra, that doesn't have a specific dedicated Julia package, and that's holding you back from using Julia, maybe consider trying to develop a package for that in Julia.
Would you help someone if they run into that issue and they happen to watch this podcast? They're like, hey, is anyone working on that data set? Would you be willing to help them, or how would they go get help to start making this contribution?
They would, of course. So the thing is, they need to know how to access the data first of all. So once that is done, then we can also help them with like back-end multiple dispatch, tell them tips and tricks to watch out for when you're creating your own packages, so you don't fall into the pitfalls that I did when I first started like 5 years ago creating packages. But there's no substitute for doing it yourself and knowing that it works yourself. So when I think about call to action for Julia, this is my call to action for the wider community, especially if you are in climate science and climate data and are using Julia for analysis, but you also need to use Julia to download data or to retrieve data. There are ways to do that, and we need more people doing that because I can't do it for everybody, unfortunately. Yeah,
but
even for NASA precipitation, like precipitation data sets for NASA, for example, the data sets themselves, there are many different data sets in NASA precipitation and I am focused on developing for the ones that are most commonly used. But if you are using a data set that is not as commonly used, we appreciate help for pull requests and issues. If you need this, let me know so I can focus some attention on it. Or alternatively, if it's a different data set, for example, I do ERA 5 reanalysis as well. But if you're interested in MERA 2 reanalysis or JRA 55, think about maybe consider helping out as well in this aspect, it would really help to develop the Julia community as well. And that's how I got involved in the Julia community as well.
And one thing I do want to point out here is that if you want to get help, getting help, right? Then one thing that you could do is you probably go to the Julia Discord, that's or the discourse, right? The discourse.julialang.org. I believe everybody at this table is a regular person who posts questions and answers on the discourse. So if you do want to say, hey, look, can I get this file format going? I tried this. I needed a little bit of help fixing a few bugs. I do think that you can find everyone here for that. So that is one area that I think that we can definitely improve on. And let's go around and
I wanted to make a point directly to that. So I think that I don't think it's necessary to have, or hopefully it's in the future not necessary to have a package for every data set that is out there, because as I see it in the Earth System Science data community, there's also convergence across metadata standards like spatiotemporal asset catalog, so that at some point it shouldn't matter whether you want NASA precipitation or ERA 5 or some European satellites. But I think we should need we would need the tooling to handle with that. And I think Alexander started a stack package, but I think that could be much nicer. It would be cool to be able to say I have this stack metadata catalog, and now I can handle it as if it's a raster data set, so I can just work with it, but there's still some rough edges there. And I think that's also something that we would need to work out.
Alrighty, yeah.
Yeah, I think there's an overarching call for action. We heard this a little bit from Makie. It's definitely also about documentation. Don't get me wrong, I find the whole Julia-based documentation, I think that's mostly great. The whole community having a Slack, Zulip channel, discourse forum, I can usually, if I have a question, I get an answer within a few minutes, and that's fantastic. Most of the questions, though, that I have are quite general ones, but small, so that you can answer them usually in a few sentences. Should I do this? Should I do that? But especially the packages that are not necessarily used by everyone, which are, let's say, a little bit more niche, but super important, a lot around the GPU stuff, a lot around things like enzyme, are not necessarily, also because they are obviously in a way more experimental state, are not necessarily as well documented. And this is something that, let's say, not level 1 developer, but the level 2 developer, the person who is kind of using it, would like to use it a bit more intensively and would maybe even contribute a little bit, holds them back. And I think this is definitely something where we also have to get together and just say hey, can we just make sure that these things are documented to get more people on board?
Yeah, and I want to follow up on Felix's comment. So I think it's you put it really nicely that data providers should not just say, here's the data and I have a Python package to load it and call it a day. They should rather focusing on standardizing the endpoint, having some standard compliant endpoint that the data can be used for any packages. That's I think really great. And for stack.jl, so the idea was to make a package with some minimal dependencies, so that you can essentially easily get the URL of the data and then use it with NC datasets or ZAR or raster to get it. But now with what we have in the Julia, these weak extensions or the extensions, that's a really great tool to even deepen the integration without creating a hard dependency. That would be really great way forward.
So there's one thing that I think is becoming more and more common amongst younger folks and students, which is when they want to understand coding, they go to ChatGPT and things like that. I'd find it, I think, very useful to have kind of a curated interface like this with a way for us to dialogue and say, tell me what's wrong with my package, or where are sort of the ways to improve it. Something that would have been curated by, maybe the innermost community to sort of point us in the right directions when it comes to improving our documentations also, for example. So that's one aspect that I think, if this was available and it's trusted because, it's not some random company doing it, but it is a Julia Hub, for example, that vouches for it, would be super useful. Another thing that I always sort of struggle with when I'm considering using a package that is out there, somewhat active, I'm never too sure. I like to know before I commit to a dependency that it is going to be maintained, and that in the past there has not been a huge latency in sort of addressing issues. Again, I don't know what shape that takes, but maybe a dialogue or chatbot to that effect might be useful, or some ways to evaluate package along certain criteria.
All right. Nobody else? Okay. So we do have other asks. So you guys gotta have an ask, right? You can't. Julie's just so good that there's nothing that you'd ask for. I mean, okay.
Yeah, I got like a follow up on what Milan said and an ask after that. I think I was thinking about this problem of documentation at JuliaCon, and it seems to me that like Julia developers often develop a lot more packages than Python or R developers do. And for me, I know I couldn't develop the packages I do in R, nowhere near the amount, but you can't, the time taken to write the documentation remains the same across languages. So we end up with this situation where we can maintain an amount of code, but we can't maintain that amount of documentation. And I think in a lot of places we're hitting that wall now where we're going for another level of professionalism in the documentation, but we actually don't have the manpower to do that. We're very lucky in Julia Geo and Earth Science packages. We have Lazaro Alonso, who does amazing documentation, but he does a lot more docs in my packages now than I do. And those people really need to be brought on board more and respected. For me, the thing that my ask is I would love, and in my field, we really need the R source compilation folder to be able to contain Julia. At some point in the next couple of years, if I can put Julia files in an R package, and that is all automatically compiled with the same toolchain they currently do Fortran, and well, with a different toolchain, but in the same way Fortran and C++ is compiled, that would be enormous.
So like RCPP, but like with Julia. Yeah, I think.
Yeah, for Julia.
I've seen a few things like that where people are like, yeah, if it, Julia is this kind of thing that's for fast programming. A lot of people in Python and R are using C and Fortran as the backend to a package because it's fast. What about having Julia as the underlying binary that is then just wrapped from a R and Python package? Yeah, I think I've heard a few asks for that as well, and I think that is
we've got tree shaking now, and we're getting closer, but we still don't have any of this tooling, and it's still kind of unreliable. But like getting that more crystallized and like as a real thing that R would add to their the compilation toolchain.
Yeah. I mean, just because you can make a binary doesn't mean it's easy to make an R package on a Julia package, and that's a very concrete ask that very few people could probably be making that kind of interface, but that is a very concrete ask that I think could open up the community to a lot more developers. So I think there's a few more people who have a request to make, or demands.
So just in reply to what Raf said, I think I tried that a couple of months ago. Didn't go so well, but all the tooling, the potential for the tooling exists. It's not technically impossible. It's doable. Someone just has to do it. And I think that someone is probably someone who has a vested interest in being able to use Julia from R. In terms of my personal ask, I would say, as a package developer, this time I went to JuliaCon, I met 5 or 6 people who used GeoMakie, who I would never imagine used it. I met astronomers who use this stuff, right? And I wouldn't have known that if I hadn't met them. So I think for all of us using packages, right? Maybe you just message us saying, "Oh, I use this thing for a cool problem," right? Or maybe if you have a confusion from the docs, if something doesn't make sense, you don't even have to make a PR, although it would be nice if you did. But just raise an issue saying, "Hey, this is confusing. I think this could be better phrased like this." It just accelerates that process so much more.
Yeah. One thing I'll continually say throughout different episodes here is if you use an open source package and you do academic work, cite the package, because you don't know who you've made excited, because when it comes time to write grants and everything, your favorite package is always trying to find out like, oh, who's actually out there using it, because I need to be able to show that it's getting a community. And so if you cite the package, that's how you're going to be able to help them get more people to be able to help develop the package. So yeah, I mean, so reach out to the developers, tell them like, oh, I love using your package, but also cite their package. All these things together is very helpful, more than you might even imagine. I think we still got a few demands.
So this is a personal pet peeve of mine. I would love to have reverse dependency testing in package built in, because we have so many dependencies that we depend on, and sometimes they break, and then suddenly it breaks for all Windows users, and I don't notice it. So painful thing, but personal. I think a shout out to, but that's for developers, right? So for all users out there, please report bugs and other integration issues you run into. Absolutely essential.
We actually fix them.
Because it's like suddenly, wow, there's a user of my package, so I'm definitely motivated to fix it. But otherwise, we just don't know. It works for our use cases. Otherwise, we would have fixed it already. And we're really deep down in our own workflows. And I mean, Alex Gardner has been absolutely essential for fixing or reporting integration issues within the whole Julia Geo and Julia Yo ecosystem. And we've been able to fix many of them. I think also maybe 10 issues this week alone. So please report bugs and integration issues. Thanks.
Sorry, I'll do two quick ones. So if there was a way for me to just submit the project TOML associated with the paper I write, and that would get counted somehow within the Julia Observer, I think that's a very concrete thing, could be done. I'd do that. Otherwise, I don't really know how. I mean, I can put a long list of packages in an appendix somewhere in a paper, but how does that information really percolate? I don't know. So like a tool to just do that, I think would be good. My others are very specific ask is, I'd love to have somewhat more native support for Pluto notebooks within Documenter, because I always end up writing a little loop that goes in my example folder, runs my notebooks, then moves them into the place where the documentation gets built. And so I'd love to have like a native support where I just give a list of things and it does something like that for me.
Well, for me, I think you already answered that my call is going to be fixed because you guys are going to develop a banner builder, which is amazing. Because when you have to run big simulations, you don't really care about the interactivity. Something I would ask probably is, I know there exists, but probably they're a little bit difficult to use, better profiling tools for pre-compilation, and how to fix pre-compilation problems, and how to snoop inside the pre-compilation and try to fix this issue.
Yeah. So one thing that I do want to point out here is that everyone who's watching this video, you should like, comment, and subscribe to the YouTube. Like you gotta say it, right? But for the comment, if you don't know what to comment, I think that one thing here is that a lot of people made a bunch of different asks, right? How many of these asks are common across the general Julia ecosystem and other viewers, right? So if you're also asking for the same thing, comment and just say, hey, look, I'm also interested in this, because it's really good to get that feedback. As was said over here, right? That feedback is really helpful. Sometimes you don't know if anyone really cares. You're like, oh, should I really, spend my time, doing Pluto notebook integration with a Documenter? You're like, I don't know. I've heard one person ask for it, but like, there's 7 billion people in the world. If there's only one person asking for it, do I need it, right? But if in this video you just say, hey, look, if there's 50 comments that just say, oh, I also wanted that, right? Then whoever watches this might be like, oh, you know what? Maybe that is worth my time. You know what? Actually, I know how to do that in one weekend. Sure, and it suddenly exists. So yeah, feel free to comment about what you've heard here and what what things you're agreeing with, or also spicy takes are also great. Do the downvote and say, I want something else, go for it, whatever. Now, I think that we're running out of time here, so we're at the very end. What I want to have everyone share now is just what is your own personal development goal for the next year. So what is the thing that you plan to be working on that you'd like to share to other people? Like, I plan on solving this problem, and I think everyone else will be able to find this so cool by the end of next year. So you want to share what your development goal is?
Absolutely. By the end of the year, I want to be able to run Speedy Weather on just a single GPU, but at a speed so that all of the climate modeling centers that are using like thousands of CPUs for that would be just like blown away. And I'm like, I can do that on a single GPU, on a single GPU. That would be great.
Okay, so blowing away all the other climate models with just one GPU fan. All right, and next?
I got a lot of little ones, like mostly like ecosystem integration. We need heaps of packages in the geo space to just work together better and just to have really tight syntax because everything just works automatically. And of course, I want my packages to be 10 times faster than everything else.
Yeah. So package integration, but also on the side, just make it all 10 times faster than anything else that's ever existed before. All right, awesome. And next?
Personal development goals, probably to integrate my packages better with Julia Geo as a whole, probably that, and graduate.
Graduation's also a major goal, yeah.
So I'm currently working on this pyramid scheme package where you can basically interactively plot and visualize large-scale data, and that works spatially at the moment very well, but I also want to dig into how to do that also in the temporal domain so that you can go from 5-minute interval things on a 20-year basis and just plot them as well and make that somehow work.
Amazing.
Okay. My goal for next year is challenging the monopoly of basically one of the only ocean models used in Europe that is called Nemo, which has basically a monopoly, and I want to get the package to a point that is recognized as a real competitor and maybe even beat Nemo. I don't know, probably not, but let's see.
Well, I'll give you two. One is I've been building this digital twin for ocean robots framework where I've brought together a lot of the observations in a practical way and a lot of the models in a practical way. This year I'm focusing on the AI piece in the middle. And I want at the end of the year to have something that's beating the competition on that in terms of the ease of use and the applicability and the practicality of it. A second goal, which is even kind of more scientific, is want to build this application to track marine heat waves that are one of the symptoms of climate change in the warming ocean, for which I think we have, in this room, a lot of the pieces we need. So I want to put that together and have something that allows us to make progress in addressing this pressing issue of the warming oceans.
Yeah, so I think I've got two goals as well. One is really firming up ecosystem integration in Julia Geo and kind of working on this whole idea of geometry processing on the sphere. So we represent points as latitude and longitude, but in reality, they're something in 3 dimensions on the surface of this sphere or ellipsoid, right? So that'll be pretty cool, pretty useful. Otherwise, I also want to make Makie plotting a lot more seamless. There's a lot of problems right now with lines in nonlinear domains like geospatial projections where it just the line remains a straight line when it should actually be a curve. And so that's something that I want to create a nice interface to fix and stuff like that.
Yeah, I want to repeat also the integration, which would be very important topic to work on, and especially now that some packages like rasters and disk array have emerged as standard across the Julia Geo community. So that's very good to improve upon this. Another thing that I would like also is to work on multi-GPU training for machine learning and cross-platforms or multiple vendor GPUs.
Good question, Chris. Nice to put us on the spot like this. It will guarantee some results. That said, I will bite. I want to make cloud-optimized formats work better in Julia. So I want to have geo-arrow working, and then you only need to download a specific subset. So your spatial region of interest, only download that instead of the whole file. That would be nice.
Okay, so now you know what is guaranteed to exist by the end of next year. Probably it's going to be more like 6 months, 4 months, yeah, for most of these features. So no, the reason why I want to kind of end on that note is because as we mentioned, comments always really help out. So if there's any of these features that you're really interested in, egg on our developers is the wrong word. What's the phrase? Cheer on our developers by saying in the comments like, "Oh, I'd be really interested. Oh, I didn't know anyone was working on that in Julia." Get in touch with these folks. And if you're interested in contributing to similar topics, get in touch and just say, "Hey, I didn't know anyone was going to work on, trying to make multi GPUs work out, or try to make plotting on spheres work out well, and all this." Right? If any of these features are interesting to you, also tell people that you like what they're doing and get in touch and say, "Hey, look, I got open hands as well." So I think that's a pretty good spot to end. We're about at the hour. I think we got to meet everyone. Please let me know if you like this format for the podcast. This is the first time we did it in person at an event. I'm going to be going to a whole lot of Julia events. Right? There's going to be it's not announced yet, but there's going to be a Julia event in Berlin like next week, and then week after there's going to be one in Trondheim. If you want to see more of this, where we're just going around asking all these developers what's going on, please let us know. This one was a very special kind of setup because the conference had a whole camera crew and everything. So, please thank the camera crew for doing an amazing job. Thank Joao for putting on this amazing Julia EO 25, and thank the entire island of Terceira for being an amazing, beautiful place to be and potentially live. So that's a whole story. But yeah, so thank you everyone, and signing off for this episode.